Hello class, I am Mr. Sutton and today we're going to be talking about Skill 10, Factoring Difference of Perfect Squares. So what is a difference of perfect squares? A difference of perfect squares is something like this, and it's exactly what it says it is. So a difference means we are subtracting, right? And perfect squares meaning we're subtracting two perfect squares. So like here we have x squared, that's a perfect square. And 9 is also a perfect square. That is 3 squared is the same as 9. So you could also think of it like this, where x squared minus 3 squared, where we can tell that these are both clearly perfect squares. So now let's think about how we would factor something like this. So usually when we are factoring quadratics, the middle term is very important for how we factor, but these difference of perfect squares are unique because they do not have a middle term, right? They just have two terms, our squared term and our constant at the end. So let's think about how we would factor something like this. So if we have x squared, then the two leading terms would both have to be x, right? It's the only way we can get x squared. So we would have x times x would give us x squared. And similarly, to get the 9, both of the trailing terms would have to be 3, right? That's the only way we can get 9 is 3 times 3. But it's a negative 9, so that means that these have to have different signs. This has to be a plus, and this has to be a minus. So let's go ahead and uh, distribute this, FOIL this, or use your box method and see if we get the same thing that we had up here. All right, so I went ahead and I took this x plus 3 times x minus 3, and I did the distribution method. So x times x gave me x squared, x times negative 3 gave me negative 3x, 3 times x gave me 3x, a positive 3x, and then 3 times negative 3 gave me negative 9. So that's what I got here. And I went ahead and did the same thing with the box method if you prefer that. So x plus 3 along the top and x minus 3 along the sides. And I got pretty much the same thing. The only difference is the middle terms are flipped around just from the way I set it up, but that doesn't matter. We can flip those terms around. But notice what happens here is usually when we combine the middle term, we end up with something in the middle, right? But since this is a difference of perfect squares, and this is what always happens with a difference of perfect squares, the middle term cancels out. So we have negative 3x, positive 3x, cancels out. Same thing if you did the box method, positive 3x minus 3x cancels out. So we end up with x squared minus 9. And that's why the difference of perfect squares does not have the middle term, because you're always going to end up with a positive and negative of the same thing in the middle. So they're going to cancel each other out. So that is why the difference of perfect squares does not have that middle term. So the difference of perfect squares, we like the difference of perfect squares because we can generalize it very easily. Once we recognize it's a difference of perfect squares, there is a way that we can factor this that works every time. And basically all you have to do is, so here I have my difference of perfect squares, a squared minus b squared. Those are both perfect squares. So you take the square root of the first term, which would be a in this case. The square root of a squared is just a. And that becomes your leading term for both of the factors. And then you take the square root of your second term, which would be b in this case. The square root of b squared is just b. And that's going to be your trailing term for both of these factors. And then you just alternate the signs. That is always how you factor difference of perfect squares. Make sure you put this down in your notes. This is the most important thing for this lesson. You can call this the difference of perfect squares formula. I'm just calling this the difference of perfect squares generalized because it's not really a formula, but you can think about it in that way. So, and we can even check this. I can take a plus b multiplied by a minus b, and we can actually multiply these out and see what we get. So a times a is a squared. A times negative b will give me a negative ab. And then b times a would give me a positive ab. So that's that middle term that's going to cancel out. and then b times negative b would give me a negative b squared. So those cancel out. We're left with just a squared minus b squared. So yes, that works. I think the trickiest part about difference of perfect squares is just recognizing that something is a difference of perfect squares. Because if you forget about that, then you might see one of these and be like, wait, how do I solve this? But once you recognize that it is a perfect square, a difference of perfect squares, then we can just apply that generalization that we talked about on the last slide. So make sure you take note of all the ones you're practicing on. Make sure you're looking at these and trying to internalize what a difference of perfect squares looks like. A lot of times, if you see, two terms with a minus sign in the middle, if you're trying to factor, then most of the time that is going to be a difference of perfect squares, unless it's just something that doesn't factor. So let's take a look at this first one. We want to apply that generalization. So we take the square root of the first term. So square root of x squared is just x. We take the square root of the second term. Square root of 16 is 4. And we put in plus and minus. And that's all you have to do for that. That is how you would factor that. Now let's take a look at this next one. Square root of 4a squared. So we have to think about what is the square root of 4 and what is the square root of a squared. So that would be 2a. And the square root of b to the 8th power. So that would be b to the 4th power. Right? If I had b to the 4th power squared, remember when you raise a power to another power, you're multiplying those exponents, so that would give me b to the 8th power. And we would have plus and minus in between. So that is all you have to do for that. That is your answer. All right, let's take a look at the next one. 25x squared, square root of 25 is 5. Square root of x squared is just x. Square root of 121 is 11. And then we add our plus and minus in between. That's all you have to do for that. Finally, this last example. Square root of 49 is 7. The square root of y to the 4th is y squared. And the square root of 1 is 1, right? Think about 1 squared is 1 times 1, which just gives you 1. So 1 is a perfect square. And I think that is one that we're going to forget about a lot. A lot of times we'll see something like this and we won't recognize that it's a difference of perfect squares because that 1 throws us off. We forget that 1 is a perfect square, but it is. 1 times 1 is 1, so 1 is a perfect square. Those are all of the examples I have for today. Again, I think the trickiest part about difference of perfect squares is recognizing that it is a difference of perfect squares. So for this assignment, you'll have the benefit of knowing that it is a difference of perfect squares, so you can just go ahead and apply the generalization to all of these. But in the future and on tests, you might not necessarily know it's a difference of perfect squares. So I think what you want to do when you are doing these problems is really look at what the problem looks like and internalize what a difference of perfect squares looks like so that you'll be able to recognize those in the future, so that when you're just told to factor something and you're not told that it's a difference of perfect squares, then you can recognize that and then know how to factor without getting stuck on it. So definitely do that when you are working on these problems. Make sure you have all of these examples written down in your notes, and I will see you in class. Sign up for office hours if you have any questions. Have a good day.